Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons.
Iron is one of the useful metals, very useful, widely used because of its many properties. Being a strong metal, being a metal that has a high tensile strength, being a good conductor of heat and electricity, being a highly malleable and ductile metal, it is widely applied in everyday life. So this iron, we don't have it as a pure metal, or we don't have any site where they extract it in its pure form. It is instead existing in its impure form, we usually know as the ore. The ore that is commonly known is the haematite, common ore of iron, that is iron 3 oxide. This ore consists of a number of impurities, which is, and one of the commonest impurities in the ore is silicon dioxide, which is silica. Remember, we should not forget this kind of an item. This kind of a process is and can set an item in section B, part 1 of paper 1 chemistry. Don't forget still that one has to state the raw materials first for this process of production. So the raw materials for the extraction of iron from its ore is the ore itself, the haematite. We shall need the limestone, which is commonly known as the calcium carbonate. We shall as well need coke, which is a carbon containing mineral, as the key raw materials. So this process involves feeding the ore into a furnace from the top, as we follow it with the limestone and the coke. We also need air, because I'm going to find that it is a crucial requirement. After putting all these raw materials into the furnace, we usually feed in hot air from the bottom into the furnace. In the hot air, there is oxygen. The oxygen reacts with the carbon in the coke usually to form carbon dioxide gas. As more air is fed into the furnace, this formed carbon dioxide will continuously react with more of the coke in the furnace. Remember I said in the coke there is carbon, to form carbon monoxide gas. The formed carbon monoxide gas is always formed to reduce the iron 3 oxide in the ore to form the iron. And carbon dioxide gas. So this formed iron is in molten state. We usually call it pig iron. Pig iron is still consisting of the impurity, which is the silicon dioxide. So the formed iron still consists, it is in molten state, but it is now consisting of the silicon dioxide because we haven't eliminated it. So the calcium or the limestone will be heated at this stage to form the calcium oxide and carbon dioxide gas. This formed calcium oxide reacts with the silicon dioxide. We react with the silicon dioxide to form calcium silicate, which is a light waste we call the slag. It is a light waste that will float on the formed pig iron or the molten iron. So we are seeing that we are now separating the impurity silicon dioxide from the required product, which is iron. The formed iron is then tapped off from the bottom of the furnace, and it is actually passed over or put in the molds, where it is passed over very cold water or air to solidify, and it will be ready for use. And what is remaining is the slag, because the iron is tapped off, which is also tapped off later for other uses, for recycling. So the process of production involves the oxidation and the reduction processes, reduction and oxidation reactions. We are seeing here the carbon is being oxidized to carbon dioxide. We are seeing here the carbon dioxide is being reduced to carbon monoxide, and the carbon being oxidized to carbon monoxide. We are seeing in this reaction the iron 3 oxide is being reduced since on it is removed oxygen. And we are seeing its oxidation state is reducing from a certain value, a certain positive value, to a 0. So in short, this is the process of extraction of iron. Involves heating the coke the carbon in the coke first in presence of oxygen in the air to form carbon dioxide. The carbon dioxide formed is further reduced by the carbon still in the coke on further heating. All these reactions involve heating. Heat must be there for them to proceed. We are seeing that the carbon dioxide formed is reduced to form carbon monoxide, which is a reducing agent we need to use to reduce the iron 3 oxide in the ore to the required iron. This iron is in molten state, but still consisting of the impurity, which is silicon dioxide, that needs to be removed so that we remain with pure iron, free from it. So this is when the limestone comes in after being decomposed by heating to calcium oxide, the calcium oxide will react with the impurity, the silicon dioxide in the ore to form calcium silicate, which calcium silicate exists as a very light waste we call the slag that will float on the formed molten iron. So the iron is then tapped off to molds of shapes we need and cooled so that we get the iron in any shape we need to use. Remember we said these kinds of lessons are important and good since we can pause, rewind, forward where necessary. Don't forget to subscribe if you really like what we do, to like and share with others. Don't forget to share with your friends.
So what is this Coke we added? Coke isn't the drink. It's a special type of fuel made by heating coal in the absence of air. It's almost pure carbon, and it does two incredibly important things in the blast furnace. First, it burns at extremely high temperatures, well over 1,500 degrees Celsius, that's 2,700 degrees Fahrenheit. This intense heat is needed to melt the iron ore and get the chemical reactions started. It's the fuel that powers the entire process. Without the heat from the burning coke, nothing would happen. The furnace would just be a cold tower full of rocks. The second job of coke is even more clever. As the coke burns, it creates a gas called carbon monoxide. This gas is the real hero of our story. The carbon monoxide is very greedy for oxygen. It floats up through the furnace and pulls the oxygen atoms away from the iron ore. This chemical reaction is called reduction. The carbon monoxide gas essentially steals the oxygen, leaving behind pure liquid iron. This is the fundamental chemical trick that allows us to separate the metal from the rest of the rock. It's a brilliant use of chemistry to purify our material. Now, what about the limestone? What's its role in this fiery drama? The iron ore isn't just iron and oxygen, it has other impurities like sand and clay. These are earthy bits we don't want in our final iron. The limestone is our cleaning agent. When the limestone gets hot, it undergoes a chemical change and reacts with these impurities. It combines with all that sandy, rocky gunk to form a light, glassy, melted substance called slag. The slag is basically the waste product of the process, a collection of all the stuff we want to get rid of. As everything inside the furnace gets hotter and moves downward, it all melts. We now have two different liquids sloshing around at the bottom of the furnace. Because the pure molten iron is much heavier and denser than the slag, it sinks to the very bottom. The lighter slag floats on top of the molten iron like oil floating on water. This separation is fantastic because it allows us to collect the good stuff, the iron, and get rid of the bad stuff, the slag, separately. The blast furnace has done its job perfectly. The moment of truth has arrived. At the bottom of the giant blast furnace, there are special holes called tap holes. One tap hole is located lower down to let out the heavy molten iron. Another tap hole is positioned a bit higher up to drain the lighter, floating slag. Workers, wearing protective gear to shield them from the intense heat, will open the lower tap hole first. A river of glowing bright orange liquid iron, hotter than lava, pours out and flows down a channel into huge containers called ladles or torpedo cars, which are like giant thermoses on wheels. Once the iron has been drained, the workers open the higher tap hole to remove the slag. This molten waste also flows out and is collected separately. While it might be waste from the iron-making process, slag is still useful. It can be cooled and used to make things like road-building materials and cement. Science is all about not letting things go to waste. By tapping the two liquids at different levels, we can cleanly separate our valuable product from the impurities. This entire tapping process is a dazzling and dramatic sight, a true spectacle of industrial power. The molten iron we've collected is called pig iron. Why the funny name? In the old days, the liquid iron was poured into a series of molds that looked a bit like a litter of piglets suckling on a mother pig. The name stuck. This pig iron is very strong but also brittle, meaning it can break easily. It contains a lot of carbon from the coke, which needs to be adjusted. So this is not the end of the iron's journey. It's often taken directly to another furnace, like a basic oxygen furnace, to be refined further. There, the amount of carbon is reduced, and other elements can be added to create different types of steel. Steel is an alloy, a mixture of iron and other elements, that is even stronger and more versatile than pure iron. From this steel, we can finally make everything from skyscrapers and ships to spoons and scalpels.
Members, for the side effects, they are simple. We are seeing every process requires heat, there is heating. And when we talk of the word furnace, we are talking of temperatures that are in thousands, hundreds and above. So they are like accidents of burns to the people working in this furnace. And in the burning, we know that, very well know that, results in 2 wounds. In this process of production, there is of waste air. The waste air consists of very many greenhouse gases. We are looking at carbon dioxide as one of the waste gases. This carbon dioxide, when released into the atmosphere, it dissolves in the water of rain, forming acidic rains, which when on soil results into a decrease in the pH of the soil, increasing the reaching ability of the minerals, reducing the productivity of the soil. We cannot forget that the carbon dioxide as well traps heat, in infrared radiations, resulting into global warming. We know that. We well know that all these gases produced as waste gases, they do not support life. They lead to suffocation. And all these ones can be mitigated, such as we can implement recycling and reusing of these wastes, not dumping them. We may reuse them for other purposes because there are other industries that need them as raw materials. For social benefits, we very well know that this process of production requires employees. And these employees will get salaries. So the social benefit is employment opportunities. And once these people are employed, they will get salaries they will use to improve their standards of living. And when the standards of living of the employees improve, as well, the area where they live improves. We will develop as well. This process of production, we are seeing to involve buying many things such as the coal, the limestone. And as they buy them, they're providing taxes to the government. So this process of production is a source of government revenue through taxation. And the tax, we know the use of the tax is used to develop other infrastructures, like the roads they are constructing. They get the money from these things. So don't forget, we have to mention the raw materials, the process of production, side effects and mitigation of the process of production, and the social benefits. We have not to forget that in the process of production, Don't forget to mention the vessel where the process takes place, the purification, if any. There should be all processes that are involved in the production, the conversion step to the product. Like here, it was the reaction between the ore with carbon monoxide, forming the required product, which is iron. So this is the step for conversion to the desired product. We've seen a number of processes, like the reduction process of the formed carbon dioxide to carbon monoxide. So reduction is a key. The oxidation of coke when burnt in air in the furnace. All these are chemical processes that are involved. They must be mentioned. And we should as well look at the flow of the information. Don't forget to subscribe or share. Don't forget to like our videos if you really like what we do. We are Mto Online. Don't forget to reach us in case of any need. I'm Teacher Alan.